Welcome back to 3 Inquisitive Kids. Today we're going to be learning about systems of inequalities. And yes, that might be familiar to you as you've probably learned about systems of equations before. So I promise inequalities will not be that much different, and today we're going to learn its properties and how to solve it. So again, this is part 1 of the last lesson in our 8th grade Unit 9 series, and the lesson is Methods of Solving Inequalities. So last time we explored the different ways we can apply inequalities in linear equations and linear functions, basically combining all of those different areas in math that we've learned previously, so how to kind of use them comprehensively when solving word problems. Now, in this lesson, we're going to be diving more into just inequalities, actually, with, of course, our usual nod to in connections to linear equations and functions. So again, part 2 will be coming up, and that will be the last video of this series. So if you would like to be notified for that, please hit that subscribe button and the notification bell so you will be notified when we upload that video very soon. So again, these are the 2 learning goals for today. Through practice, 4 methods for solving unary linear inequalities, and to master representing solution sets of unary linear inequalities on the number line. Here's our introduction. So listen to this conversation between 2 friends. Look, this elephant is so big it must weigh no less than 3 tons. I heard from the administrator that this elephant weighs less than 5 tons. So the keywords here and the key phrases are highlighted in red. Can you estimate the weight range of the elephant based on the dialogue snippet above? Please tell us your reasoning. If the weight of an elephant is X tons, please use your knowledge of inequalities to express the contents of the conversation between the 2 students. So using inequalities, this is what it will look like. If the weight of the elephant is X tons, and we know that it's no less than 3, it can be either greater than or equal to 3. So X is greater than or equal to 3. That's our first inequality. And for inequality number 2, if X is less than 5. It says it's less than 5 tons, which means that it cannot be greater than or equal to, so it's less than. Systems of unary linear inequalities. The width of a soccer field is 70 meters. If its perimeter is greater than 350 meters and its area is less than 7,630 meters squared, find the value range of this field's length and determine if this field is capable of holding international soccer matches. Now, the requirement for soccer fields holding international soccer matches is that its length has to be in between 100 and 110 meters, and its width has to be between 64 and 75 meters. Otherwise, it is not qualified for holding international soccer matches. Now let's first analyze this question by reading it through one more time. So we already know that its width is 70 meters. Its perimeter is greater than, I'm going to be boxing up these keywords, than 350 meters, and its area is less than 7,630 meters squared. So now we're just trying to find the value range of this field's length. So the first step here is to always analyze this word problem and then write down the information we are given and the quantitative relationships we are given into a more easier to understand mathematics point of view. So if the length of the field is x meters, its perimeter would be represented as 2 times x plus 70 meters, and its area would be 70x meters squared. From the problem, we know that the value range of x would be 2 times x plus 70 is greater than 350, since its perimeter has to be greater than 350 meters, and its area has to be less than 7,630. So 70x is less than 7,630. These 2 inequalities are valid at the same time, which means that they have a range of solutions. So after grouping together these 2 inequalities using a bracket, we can simplify. But we don't know how to simplify it, and that's what we're going to get to later in this lesson. Like this inequality, several unary linear inequalities with the same variable can be combined to form a system of unary linear inequalities. Let's do an exercise first. Determine whether the following is a system of linear inequalities in one variable. Remember, it has to contain one variable, everything has to be an inequality, and there can only be whole expressions. Let's go through each one of these. This first one is not a system of linear inequalities in one variable. Why? Because it can only include one variable. That's in the name, in one variable, or unary. Unary also means one variable. X and Y are two separate variables, which means that this is not valid. So what about this one? This one would be considered a system of linear inequalities, and not all systems have to have a solution. Sometimes it doesn't have a solution, just like how in systems of equations there isn't always a solution. So this is actually a system of linear inequalities. Now what about this one? Well, two things. Well, first of all, this is not a whole expression, and second of all, there is an equal sign, which means that this is not a system of linear inequalities. And here, this would be considered a system of linear inequalities since it has all of the requirements. One variable, all inequality signs. So how did you solve the previous question? Similar to the solution of a system of equations, the common part of each inequality solution set in a system of inequalities is the value range of the variable included in the inequality set. So here's our summary. The common part of the solutions of each inequality of the system of inequalities is called the solution set of the system of inequalities. So there's two inequalities in one set, right? And you already know how to represent solution sets of inequalities on number lines. Now, if you were to represent two solution sets on the number line at the same time, you may see a common part where both inequalities overlap onto that area. And if it is contained by both inequalities, it means that it is the solution to that system of linear inequalities. But sometimes, remember, when there is no solution, then there may be no common part. But we're going to elaborate more on that later in this lesson. The process of finding the solution set of a system of inequalities is called solving a system of inequalities. So pretty self-explanatory. Solutions of systems of unary inequalities. Can we use the number line to represent the solution to a set of inequalities? Use the number line to express the system of inequalities. X is less than or equal to 3, and x is greater than negative 3. Well, our first step is to always draw out a number line, and then we can mark the points 0, negative 3, and positive 3. Now I'm first going to represent inequality number 1, and that is x is less than or equal to 3. So its direction is to the left since it's less than, and remember it also has an equal to sign. So that's why this point right here is filled out. But for this one, we have a empty point since it is just a greater than, and it does not include the value negative 3 itself. And it's x is greater than negative 3, so its direction is to the right. And now, let me just quickly extend this for a moment since we all know it goes on forever, so this would be valid as well. As you can see, there is a pink part and there is a blue part. But the middle part where they both overlap, this area right here would be the common part to their solution sets, which means that this would be the solution to this system of unary inequalities. Therefore, the solution to this system of inequalities would be when x is greater than negative 3 and x is less than or equal to positive 3. Let's do an exercise. Let's fill in the table. So there's 4 systems of inequalities here, and we're going to find their solution sets. Now, one good solution to solving this exercise is if you plot it all out on a number line. All right, so after filling it out, you should have these answers. X is greater than negative 3, x is greater than negative 5 and less than or equal to negative 3, x is less than negative 3, and for this one there is no solution. If you graph this on a number line, you will see that these two inequalities don't have a common part, and that is completely okay. because not all sets of inequalities have to have a solution. Example 1. Solve the inequality set from a previous example. So again, this is the soccer field problem, and now that you know how to solve inequalities and how to represent them on a number line, you can first go ahead and solve. Alright, so the first step is to first simplify each one of these inequalities to its simplest form. So simplify number 1 and you have x is greater than 105. Simplify number 2 and you have x is less than 109. So the solution set of this set of inequalities here is the common section of x is greater than 105 and x is less than 109. So let's represent these two inequalities on the number line. So we have 105 here and 109 here. The part where they overlap would be their common section. So from the model, we can see that they both overlap the section where 105 is less than x and x is less than 109. Therefore, this area, this common shaded area right here, let me just shade it in so it's easier to see. This area right here would be the solution to the set of inequalities that we have from the problem. Okay, now that we've found the value range of x, let's answer the question. It can be seen that the length of this football field is between 105 meters and 109 meters. In terms of the size of the field, international football matches can be played on this field. Now here's just another practice problem. Solve this inequality right here. Again, pause the video and try to solve it on your own. If you think you still need more practice with this, I recommend you first graphing it out on a number line, but as you get more advanced, you can start trying to just solve, and then when you've isolated the variable onto one side for each of these inequalities, you can then connect the two inequalities. So first we solve inequality 1 where we get x is greater than 1/3, and then we solve inequality 2 where we get x is less than 6. Now we express the solution set of the inequalities of 1 and 2 on the number line. And this shaded part right here would be the solution set to this entire system of inequalities. And then the solution to the inequality set would be x is greater than 1/3 and less than 6. So there's going to be a lot of practice problems here because practice is what makes perfect. Or as I like to say it, practice makes progress. So let's solve this inequality now. So in this inequality, we first again solve each of these inequalities where we have x is greater than 2 and x is greater than 4. If there is a same sign, then I always ask myself, when x is greater than 2, is x always greater than 4? Well, not always. But when x is greater than 4, is x always greater than 2? Yes. So we always take that one that you answered to yes to, and then the common part would be x is greater than 4. Now we can also do this more geometrically and less abstractly and see how this plays out on the number line. We have two inequalities and they're all facing right and they're all in the same direction since the sign is the same. But the only part where they overlap is the whole of the second inequality right here. So the common part would be when x is greater than 4. Class summary. Today we learned about systems of linear inequalities. And we got to the concept of systems of inequalities, where we learned about how to solve it, solution sets of systems of inequalities, and representing the solution sets of systems of inequalities on the number line. And how did we solve? Well, we first solved each inequality in that system, and then we represented the solution sets of each inequality on the number line. Finally, we would find the common part of the solution set and then find the solution. The two skills that we worked on today is through practice 4 methods for solving unary linear inequalities, and to master representing solution sets of unary linear inequalities on the number line. Thank you so much for watching through Inquisitive Kids. Remember, part 2 is coming up to this video, so if you enjoyed it and you would like some more through Inquisitive Kids videos, please make sure to hit that subscribe button and the notification bell so you will be notified when we upload our future videos. Again, thank you so much for watching through Inquisitive Kids, and we'll see you next time.